Hi, I'm Josh. I work at Slack. I'm the head of data engineering over there. I used to work at Cloudera. I used to work at Google. Used to work at some other places. I wrote a popular tweet about data scientists once, and I don't want to really talk about it anymore because it's been retweeted like 10,000 times and it's kind of exhausting. And I only own the one hat, which sadly I forgot today. So in my career among Google and Cloudera and Slack, I have done a lot of data engineering and I have done a lot of data science. I've been on both sides of this fence. And so that was, I guess, the reason why I was asked to talk about bridging the gap between the two. And so I honestly struggled with this topic. It's hard. I work at Slack now. I have a real job. When I was at Cloudera, like my job was pretty much to give presentations. And so I got really good at giving presentations. But I eventually kind of stopped talking about new things. And so now I'm talking about something new, and I'm trying to figure out what exactly to say about it. And I'll be honest with you, I had kind of a rough week with my data analytics team at Slack. So my first question is, why should we bother bridging the gap between data science and data engineering? Like, do we actually need to do this? Is this actually worth doing? I'm asking honestly right now, I guess. Like, seriously, like, yeah, do we? Yeah, kinda. I don't know. Like, why bother? Like, data. I mean, for me, it's like data engineering, data science. These are two very sexy, very attractive jobs. But we spend most of our time kind of in couples therapy, I guess, like working on our relationship stuff. And I wonder why that is, because things start out like so well. If you ever get the chance, or if you personally have had the experience of ever being like the very first data science, data analytics, data engineering person at a company, and you're like by yourself, it's like those people are so sad and so unhappy. Like they really are. They like really, the first like data engineering person, they want nothing more than like a data analyst person to come along and like write SQL queries and dashboards so they don't have to anymore. And the first like data science person, if they happen to be first, all they really want is like an engineer who will just like get them data and provide them with data they need that they can't get themselves. So like we sort of long for each other. And then, you know, like if your company succeeds and like you actually manage to hire that first data engineer or that first data scientist as sort of a compliment, things are usually like okay for a little while, but where I find like the problems, sort of the source of the problems between data science, data analytics, and data engineering really come down to the fact that we fundamentally want different things. And you can actually see that if you look at the titles of the presentations of the like different tracks today. So I did this thing, I did a very advanced analysis called word count on the titles of the talks. And the most sort of frequently used words in the data science track, besides, you know, obviously data, right? Data's used everywhere, were systems and learning. Systems and learning. And most of the talks focus on like machine learning or some kind of system for doing recommendations or something like that. And the most popular word by far in the data engineering talks is scale. That's really, we're sort of talking about different things. Like data scientists want the ability to like explore data sets, discover insights, discover sort of new information, new metrics, quickly get those values, get that information into production, into a position where it can be used to help people make better decisions. They want to do kind of fancy, cool advanced analytics, fancy, cool machine learning, impress other data scientists, all that kind of good stuff. Data engineers, on the other hand, really want efficiency. They want reliability. They want high throughput. They want low latency. And more than anything, what they want is scale, because nothing impresses other data engineers quite like scale. And these sort of two wishes, these two goals aren't like necessarily perfectly compatible with one another, and that's sort of where the divergence, excuse me, between us starts to happen. So what sort of seems to happen over time as data engineering, data science teams grow is something that I call the infinite loop of sadness. And I've coined this term. I think I'm going to trademark it actually. This is the infinite loop of sadness. Let's kind of walk around the infinite loop. So let's start with the business, all right? The business makes unreasonable and ill-informed requests of the data science team for basically information and answers to questions that are either like completely irrelevant or not possible using the data they have or methodologically inappropriate, something like that, right? Basically, the business makes ridiculous requests of the data science team. The data science team, in turn, makes ridiculous requests of the data engineering team. Like they want to do everything in, I don't know, probably Python or something like that, using GPUs and all kinds of crazy shit like that. The data engineering team, in turn, makes ridiculous requests of the operations team to run stream processing engines that barely work, that can't be monitored, all that kind of good stuff. And the ops team basically then goes to the business and says, holy crap, we need a lot more money to support all of the stuff that we're doing right now. And of course, like, things flow the other way too, right? The data engineering team feels that the ops team puts onerous constraints on like what the data engineering team can do. The data science team feels that the data engineering infrastructure is very limited and not flexible enough for what they need. And the business feels that the data science team can't answer any questions that they want. And the business is like, well, maybe we should just fire all these ops people and outsource them to someone else. So everyone in this sort of circle is constantly trying to outsource the other person they depend on, roughly speaking. This is the world most of us inhabit. Like, let's be honest, right? This is the way this works. It's very sad. Hence the infinite loop of sadness. So, as a result, we're sort of like alone together. There's a very strong temptation, I think, in data science and data engineering to sort of go off into our own little worlds where we don't really have to kind of deal with the other person so much. So you have like the data engineering team off building, crazy stream processing engines and sort of streaming data flows to power production systems because they don't really need the data scientists to do that. Like, there's requirements and they're well defined and the latency and all that kind of stuff. It's a very clean, good engineering problem, and so the data engineers go off and do that. And the data scientists go off and they build their own kind of like de facto, sketchy, crappy data engineering infrastructure so that they can do things the way they want to do them. So lots of, like downloading massive data sets onto their desktop and loading them up in Tableau or R or whatever and all this kind of stuff. So we're alone together, basically. We're not really like working that well together, and this is very, very sad. And so I think I'd like to sort of fix that. And the way we're going to fix that is sort of starting with first principles. The first principle of building any data infrastructure is that you only need to understand and appreciate two things, Apache Kafka and Franz Kafka. And the Apache Kafka part, I think, should be obvious to everyone by far. Like, Kafka is like oxygen, you know what I mean? Like, saying you use Kafka is like saying you use Linux. It's like the least interesting statement in San Francisco. But the Franz Kafka part is actually, I think, interesting and important. And I'm going to turn to David Foster Wallace. He wrote this great essay about sort of Kafka's sense of humor in this book. He wrote it like the essay somewhere, but it's in a book called Consider the Lobster. And he sort of gives this whole paragraph, which I'm not going to read to you because I don't have that much time, about sort of Kafka's sense of humor. But like, the idea is the central joke in Kafka's writing is that the horrific struggle to establish a human self results in a self whose humanity is inseparable from that horrific struggle. You want to envision readers coming up and pounding on something. Like, imagine Kafka's art as a kind of door, and envision readers coming up and pounding on this door, pounding and pounding, not just wanting admission, but needing it. We don't know what it is, but we can feel it, this total desperation to enter, pounding and pushing and kicking, et cetera, et cetera. And finally the door opens, and it opens outward, and we were inside of what we wanted the whole time. And that's comedy, obviously, in a very sort of bleak, well, Kafkaesque sense, I suppose. But the reality is that the struggle to build data infrastructure results in a data infrastructure that is inseparable from that horrific struggle, roughly speaking. And that's kind of the thing. Data engineers and data scientists, we need each other. The really, really good engineering problems right now exist in basically enabling the data scientists to do the things they want to do. And the data scientists do not get the world they really want to inhabit unless they work with the data engineers in order to create it. And so we need to repair this relationship. And the way to start repairing it is first and foremost to start with the infinite loop of sadness and sort of change our perspective and think of it as the infinite loop of empathy. Because roughly speaking, data science and data engineering have similar relationships in the infinite loop, right? The way that data science feels about data engineering is the way that data engineering feels about ops, right? So if you're a data engineer and you're like getting this sort of ridiculous incoming request from the data science team, imagine that it's like the sort of same kind of request you're making of the ops team that seems completely reasonable to you and you don't understand why you can't just go do it, roughly speaking. And vice versa. When the data engineering team pushes back on the data science team, That's sort of like the data science team pushing back on the business to say, hey, that's a terrible idea. You shouldn't do that. You should do things this way because it'll actually be like meaningful and accurate and have confidence intervals and all that kind of good stuff. So we start with empathy, and the empathy sort of flows from the fact that we're sort of in this together, right? We have similar relationships with each other that we have with other teams, and that should help us understand what it's like to work with the other person. One of the things that's really honestly most helpful for bringing data science and data engineering together is machine learning. Machine learning is a great place for everyone to collaborate because machine learning is a situation where everyone's goals are fundamentally aligned. We want meaningful metrics, we want to optimize them, we want to deploy machine learning models into production that are reliable, that are instrumented, that the ops team is happy with. We get kind of everybody pushing in the same direction at the same time. And so if you work at a company where machine learning is a critical part of what you do, and you're on sort of the machine learning focused part of the team, that is an opportunity to create a great relationship between data science and data engineering. However, not everybody does or works at companies that need machine learning or do much machine learning or anything like that. And so while that's like a good situation to be in, it's not going to solve the problem, sort of the delta between data science and data engineering for everybody. But I think there's something that can, and it's really ETL. And I love this comic strip, and y'all should read it and appreciate it because it's just so dark and twisted. Everybody ETLs. Everybody ETLs. No matter who you are, no matter where you are, everyone does ETL. Extract, transform, and load. Occasionally, I know I don't need to say that in this room, but like sometimes I talk to like software engineers at Slack and I say ETL and they have no idea what I'm talking about, which is just bizarre to me, but whatever. So yeah, everyone needs to, read in data, apply transforms to it, and write it out someplace else. That's pretty much the definition of software engineering. And there's a couple of different patterns I've seen for doing ETL that I've sort of come across in working with people from Google and from Facebook and from Twitter and all these kind of things. And the first pattern I see is what I call SQL-centric ETL. And this is, for me, in many ways, a sort of very data science, data analytics-oriented perspective on ETL. So all of the ETL in these systems is a bunch of SQL queries, it's a bunch of Hive queries. They're sort of like managed in a somewhat opaque way by an ETL workflow engine like Airflow or Luigi or Pinball, like one of these kinds of systems. And it's very much like all about SQL. And this is great for data analysts because it's very easy for them to kind of understand things and like see sort of how pipelines get defined. It's very easy for them to extend them. It's reasonably easy for them to extend these pipelines and add new metrics and have them do new things. But in my opinion, this is not really like a great environment for data engineers. Because data engineers tend to spend a lot of their time, trying to fix like very broken and inefficient SQL pipelines or writing, UDFs in Java using Hive's sort of horrible object inspector kind of unbelievable nightmare kind of thing. So this is, I think of SQL-centric ETL as fundamentally an analytics-centric ETL. It's a world that primarily benefits analysts at the expense of data engineers. And that makes me sad. And then there's sort of option two, which is JVM-centric ETL. And JVM-centric ETL is all of the real ETL we do is done in Java or Scala or something like that. And it's like very sort of elegant and highly, highly functional and relatively difficult to understand unless you have a degree in abstract algebra. But is like very reliable and very efficient and not necessarily sort of as accessible to data analysts in order to be able to go play and sort of explore and try out new metrics and make modifications to these pipelines without involving a data engineer in some non-trivial sense. And if you happen to be a data engineer who really, really likes writing Scala, this may be like a perfectly acceptable, happy world for you. But I don't think it's a great environment for most data analysts. I don't think it really meets their needs. I don't think it really makes them kind of happy. So, what I'm interested in is sort of a third way. And like most third ways, it's going to be something that makes everyone kind of unhappy. And the third way is what I've been working on right now at Slack. And I'm going to sort of I want to talk a little bit about like how I got here, like how I sort of arrived at like thinking about the problem in this way. Based on the fact that, I mean, fundamentally, if I have empathy for data analysts and I have empathy for data engineers, I really want everybody to be not happy, but at least like the same level of unhappy, I guess, is probably the best I can hope for. I can't really make everyone happy, but I can make everyone equally unhappy. Does that make sense? Like Pareto-style unhappiness, roughly speaking? I don't know why that's funny. Like, I'm perfectly serious. And that's kind of what I set out to do, or at least what I'm trying to do right now. And I think most of my team thinks I'm kind of crazy, and I suspect a large number of you will think I'm kind of crazy too, but such is life. All right, let's talk about this. A few different trends, a few different things going on right now that are influencing sort of the way I'm thinking about ETL, the way I'm thinking about building pipelines. First and foremost is the rise of Spark. Spark is, so yeah, I love this. This is the Standard Oil comic strip from like back in the Gilded Age of the 1880s or 1890s, whatever. Spark is like Standard Oil. If data is the new oil, Spark is the new Standard Oil. It has tentacles everywhere. There's literally no sort of part of the data stack that Spark does not touch in some way. And if I invented a new data processing framework tomorrow that took advantage of, I don't know, GPUs that were plugged into InfiniBand connections across a cluster, the next day Spark would have an implementation that would do effectively the same thing. So yeah, Spark is really, because of sort of its tentacles, because it touches so many different things, because of its SQL integration, because of its streaming integration, because of its memory sort of centric computing model, Spark really sort of opens up some new and very, very interesting possibilities for us that were not true before in the sort of very MapReduce or SQL-centric world that we've been inhabiting for quite some time. And especially at the scale of, like, say, Slack, which is not even remotely like big data, like we log like a few billion events a day, Spark can be really, really, really interesting for doing sort of data processing in a sort of new way. And I'm gonna talk a little bit more about that in a second. That said, the second kind of theme that's plaguing me right now is we have too many stream processing engines. So I think I just got a sample here. I didn't even include all of them. I left out Gearpump, so apologies to Gearpump. But Spark Streaming, Samza, Kafka Streams, Storm, Flink, there probably was another one invented while I was just standing here talking. We have lots and lots and lots of stream processing engines. And you know, if you're in data engineering now, you know, like at Google, there was this joke that there were two ways to solve any problem. The way that was deprecated and the way that doesn't work yet. And that's kind of the nature of data engineering right now. Batch processing is deprecated, but stream processing really doesn't work yet. That's like the situation we find ourselves in. But everything is going towards streaming. If you know for sure 100% what stream processing engine you're going to be using like 12 to 24 months from right now, I'm going to say you're either an idiot or you're like full of shit, like basically. Like no one has any idea what the stream processing engine of like the near future is going to be. There's too many of these things. They all have pros, they all have cons, devil you know, devil you don't, all that kind of good stuff. But there's lots and lots of options here. And it's not really clear to me like what is going to win, or if some new fundamental paradigm is going to emerge tomorrow that makes all this stream processing stuff suddenly make sense to everyone. So the way that's deprecated and the way that doesn't work yet. That said, just because we have lots and lots and lots of different stream processing engines to choose from, the design patterns around streaming are actually kind of reasonably well understood. There's things like Summingbird, right? So Summingbird from Twitter is essentially a pattern like library for doing unified stream batch data processing. There was a great blog post on O'Reilly recently by a guy I used to work with at Cloudera named Joey Echevarria, where he talked about like creating configuration languages to handle most of the sort of very common patterns that you encounter when you're doing stream processing. So like all of stream processing right now is essentially flat map followed by aggregations, with an occasional sort of left join style lookup into some other key value store. Like that's sort of the dominant pattern by far. And so even though there's all this complexity and all this richness around the various stream engines, stream processing models, the actual sort of core patterns we use day to day most commonly are actually pretty well understood. We have a pretty good sense of these things at the moment. And that's an interesting situation, that's an interesting opportunity. Finally, I think the fact that we have so much great data infrastructure now, so many great data engineering tools, so many like ways of handling scale and all this kind of good stuff, means that we can finally sort of focus on the real problem, which is change. This change is everyone's problem. How do we evolve these systems? How do we like define new metrics? How do we restructure the pipelines? How do we move things from a batch world to a stream processing world? Fundamentally, how do we handle change? This is the real problem. This is the problem we need to solve, much more so, in my opinion, than scale at the moment. The real problem is change. So we need to solve the real problem. So the approach that we've been playing around with right now takes some inspiration from deep learning. There's a couple of different sort of mainstream deep learning libraries. There's TensorFlow, there's Theano, there's Torch. And they all actually sort of employ a very similar paradigm. There's a sort of low-level systems language, C, C++, whatever, that's optimized for very intensive compute processing. And then there is a high-level scripting language that allows you to configure the low-level systems language and do whatever kind of high-level bookkeeping scripting tasks you need to do, right? So it's either Lua or Python or whatever, sort of on top of a low-level C++ engine, right? This is a fairly common pattern. And I think that this is roughly the right pattern for doing ETL and doing data processing right now. And I realize this is going to be controversial, and I want to kind of head off the first sort of objection to this, which is a high-level scripting language like Python or JavaScript is not statically typed. And static typing is really, in many ways, like the sort of universal thing in data engineering right now. SQL is fundamentally a statically typed language. Scala, all that kind of stuff, the way we do typing. I wrote a Java library called Apache Crunch, which was like even more statically typed than Scalding. It was like even Cryo was like not sufficient for me from a typing perspective. So for a long, long time, I've been a major advocate of static typing for data pipelines, just because there's nothing worse than writing an enormous pipeline, having it run for hours, and then like failing at the last possible second because of a type checking problem that you could have caught at the very start of the pipeline, right? Everyone sort of nods because everyone's had this painful experience at some point. Yes, okay, good, got deal. But what's interesting to me right now is I think a couple of things have changed, have basically lowered the cost of rerunning things to the point where I'm actually much more interested in Python and JavaScript for writing pipelines as sort of not just configuring them, but writing them as well. One is sort of the introduction of Spark and the fact that I can really quickly load up a data set into memory, cache it there, apply some data processing logic to it, have it fail, reload my JavaScript or Python and run it again and run it again and run it again, like interactively. So I mean, it's sort of getting to the point where like working with big data is becoming more and more like doing some ETL or processing on like a CSV file you happen to have on your machine. It's becoming sort of closer to that, and as we move closer and closer to that, the cost of static type checking sort of errors goes down significantly, and as a result of that, we can sort of embrace some of the flexibility and advantages we get from the sort of non-statically typed, dynamically typed languages. The other thing is that with languages, sort of with the evolution of Python 3 and with libraries like Flow for JavaScript, evolutionary sort of static typing, like sort of slowly evolving type systems, are becoming kind of a thing in the Python and the JavaScript communities. And this is really good news. We can kind of like type things as they make sense, add typing in places just sort of as we see fit, while still having the flexibility to just sort of hack interactively on data when we want to. So this is the sort of like the combination of these things, the in-memory processing with Spark and the sort of slowly evolving static typing or not quite static typing make using scripting languages a much more practical option, in my opinion, than we've ever really had before. So I've been working on creating a system based on these principles, based on the principle of Spark, sort of in-memory computation, based on the principle that I don't know what stream processing engine I'm going to use. I'll probably choose one, I'll probably be unhappy with it, we'll probably choose another one, right? And the fact that these sort of scripting languages are becoming interesting and possible for handling a lot of the fairly like boilerplate easy parts of data processing that don't necessarily need a full-on systems language. So in choosing between sort of Python and JavaScript, I ended up going with JavaScript for a couple of different reasons. And the main one is that I work at Slack. And if you guys don't know the origin myth of Slack, Slack was originally a game called Glitch. And actually, if you go to a 404 if you find a 404 on slack.com, this is the page you get. Glitch was this like incredibly cool game they had developed. It was sort of like ridiculously open-ended, but unfortunately didn't succeed. And essentially the company took the very last of their VC money and used it to launch Slack, which was an internal tool they had developed for themselves in the course of creating the game. But Glitch was a game, and the game engine itself was written in Java, but the level designer was all in JavaScript. It was all in like Rhino and Nashorn and that kind of stuff, right? So it so happened that working at Slack with a bunch of people who used to work on Glitch, there's a tremendous amount of in-house expertise around Rhino and Nashorn and kind of like what they're good for and how to use them and stuff like that, that I was able to leverage in creating some of the stuff I've been working on for ETL workflows. And this is roughly what I've come up with. So again, keeping in mind the sort of spirit of deep learning, there's a mix here of configuration stuff and just sort of full-on flexible programming stuff. But the way this model works is you create a JavaScript file that imports some sort of core libraries of the framework. And one of the things you can do, kind of obviously, is define output tables that this ETL script is going to run, that's going to generate. So you basically give a table a name, you specify a set of fields, and you say that, hey, aggregation engine, processing engine, I want you to group by these fields that will come in some record, and sum and aggregate these other fields. And you can define multiple tables in a single script, and we will do all of the kind of table processing at the same time over sort of the same input data set. So imagine load the data set in memory. If you find a bunch of different tables, a bunch of different aggregations you're going to do, and they're all going to process exactly the same data, your best bet in Spark is to just like load the data they need into memory, cache it, and then do the processing over those tables all at once. Much more efficiently than running a bunch of separate kind of individual jobs in order to do whatever aggregations you need to do. So at Slack, our logs, our thrift logs are called slogs. Our client logs are called clogs. Our job key logs are called jogs. It started and it just kind of got out of hand. You guys know how that goes. So the reference there to slogs is sort of our thrift-based logs. And process daily actives is a function defined in the JavaScript file, which takes in a slog, extracts information from it, basically doing essentially a flat map to emit records to whatever downstream tables you have. So whatever kind of common logic for computing daily active users or any other kind of thing you want to do can be defined here in one place. It can be tested, all that sort of good stuff. All this becomes possible. And the really nice thing about this is it sort of eliminates, in many ways, the problem of moving from a DSL into sort of a low-level systems language. So there's like Hive and Pig and all that kind of stuff are great until you have to write a UDF. And the reason languages like Scalding came along were because you could basically write the UDF at the same time you were doing the pipeline, and you didn't have to like change environments. And I don't want to like lose that feature, that functionality of Scalding. I just want to enable people to do it in an environment where they don't necessarily have to learn Scala. For analysts and stuff like that, everyone knows JavaScript, everyone hates JavaScript. It's totally fine, no big deal. But it is like lingua franca, like everyone knows JavaScript. No matter what you do, you can do some JavaScript. So no need to write UDFs, no need to pop down into Java whenever you need some custom extensions, just write the code you need. But just because we're doing scripting doesn't mean we necessarily have to give up SQL. So I have come to mainly appreciate and be occasionally annoyed by Spark SQL and its integration with Hive. The fact that I can like programmatically basically look at the output tables that get generated from one of these JavaScript things and say, okay, the table's coming back with these fields. Let me compare that to the schema of the Hive table I want to write to and make modifications to the Hive schema in order to support the new data I'm writing. Like being able to do programmatic DDL in preparation for like actually inserting, loading new data sets is very, very cool and makes my life like tremendously better. Also sort of like being able to specify these dependencies between jobs is basically a way sort of expressing to whatever system is running all this ETL what data should be left in memory, what data should be cached, and what order of operations things should be done in, because we have essentially all of this structured metadata around what tables are needed when, how they need to be joined, all that kind of good stuff that we can use to optimize the overall flow of our ETL pipelines. And this is very nice compared to, say, like Airflow or Luigi or whatever, where essentially the Hive query is like basically opaque to me. And I can't necessarily tell inside of the query what all tables, like it would be really, really useful if they were like cached in memory right now. But doing all this stuff this way in JavaScript exposes all this information in a structured way to Spark, and so we can decide, okay, we're going to do this, this, and this processing, then we're going to cache this result in memory, do these joins, and then finally write everything out. And we can have a lot of opportunities to optimize not just an individual job or an individual query, but the entire workflow as it evolves over time. All right. So this is a brave new world right now, right? This is roughly like sort of the crazy ideas that we're working on at Slack as a different way of doing data engineering. A way of doing data engineering where analysts can define pipelines and make modifications to them and sort of automate a lot of the tedium of doing things. A world in which everyone can interactively load data up into memory, try out scripts, try out new ideas, play with the results, see if they're a fit, and if they are, quickly move them into production pipelines. And a world where engineers, data engineers in particular, are sort of allowed to work on maybe like one of the most interesting, truly interesting resource management data engineering problems of our time, which is basically taking this sort of arbitrary DAG of queries and jobs and all this structured information and finding a way to optimize it and finding a way to like process it all very, very efficiently. This is a much more satisfying problem for me than writing UDFs or even defining like a type theoretic library in Scala. Like this is the real stuff for me. This is what I'm excited about right now. And yeah, I think that's pretty much it. Thank you all very, very much. And you know, we're hiring, so obviously, yeah. Oh, I think I only ended up talking for like half an hour, so sorry about that. But I'm happy to take questions on this stuff or literally anything else anyone might want to ask me about. Do we have a microphone or something, or what are we doing for this? Is this a thing? There's this nice woman back here has a microphone. And I saw the guy in the blue shirt back there had a question. Don't walk too slowly, Pete. We need to kill some time. I didn't talk long enough.
Check, check. Hey. So as a data engineer, how many languages should I know, and what order should I learn them, and how good should I be at them?
Man, that is a phenomenally good question. I love that question.
JavaScript.
Exactly. It's all JavaScript from here on out. You're done. You're welcome, America. Yeah. Like, I get like a bunch of maple bacon scones thrown at me up here on stage. God damn it. No, I seriously want to answer that question. So yeah, you need to learn all of them. It is like seriously like the sad answer. You need to learn all of them. And I just like, I mean, Slack, our data engineering team is 5 people, and we have like analysts, I guess like 7 analysts or so. And let me just like walk through the set of programming languages that I use on a weekly basis, all right? So I write JavaScript, obviously, right? But I write not only like, you know, back-end Rhino-style JavaScript, I write front-end JavaScript as well because I work on the client-side libraries we use for like instrumenting and capturing events, right? So rolled our own segment, effectively speaking, with apologies to the segment IO people who were nice enough to sponsor this conference and send me cookies and other gifts and stuff like that. Anyway, PHP, because the web application at Slack is written in PHP. It's like just sort of a litany of terrible programming languages, more or less. I mean, the core application is written in PHP. PHP, as we all know, is like a web app, you know, development framework that kind of got out of hand and turned into a programming language. So I know PHP. Our ETL engine is written in Go, because why the fuck not? Our ETL configuration library, though, is written in Python, because the analysts know Python, and it's fairly easy to express these dependencies in Python. Java, because there are Hive surdays and UDFs and all that kind of stuff. Scala, because there's Scala pipelines as well. There's scalding jobs, there's Spark jobs, all this kind of systems infrastructure for the JavaScript stuff I'm talking about, all Scala. God, I think that's it. That's enough, right? That's enough programming languages for one person to work with in 1 week, roughly? Does everyone agree? In terms of order of operations, it's a great question. It kind of depends on where you're coming in. If you are the like very first data engineer in an organization, you're probably like your first job is probably to learn JavaScript and SQL. just to be like perfectly honest with you. It's kind of a heartbreaker if you've been doing a bunch of like IPython notebooks and you want to do machine learning. But really, instrumentation is like the first requirement by far. Actually collecting the data in the first place is the hard problem. JavaScript and SQL are both very, very easy to learn and will like totally get you going and get you started. If you want to join a much larger data engineering team in an existing company, I think at Facebook, you're probably going to want to learn Java. If you're going to Twitter, you're probably going to want to learn Scala. I don't know any other sort of, if you want to come to Slack, then, I listed like 6 languages. Just pick one and tell me which one you want to learn first. It's totally fine. Yeah, I think, it's not for nothing, like this, I love this aspect of data engineering. I love the fact that I get to like switch contexts and work with all these different programming languages on a fairly regular basis. That is something I enjoy. I know a lot of people, it's like Haskell or nothing, and I'm just not one of those people. So it's great for me. It's like one of the reasons I'm very happy that I chose this career. One of, actually maybe the only reason I'm happy that I chose this career, to be honest with you. But I love that aspect of it. All right, long-winded answer, killed some time, awesome. Next question. Right here, is that okay? It's like literally right up front. I'm just gonna make Pete run around. It's super fun for me.
So the JavaScript that you're working on,
Yeah.
Is any of it open source? Is there like a library or some type
No,
of?
none of it is open source, and it's more or less because like I started working on it like a week ago. You know what I mean? Which is like one of the reasons why it was hard to figure out what to talk about today, because I was like, do I really want to talk about this, or are they going to throw maple bacon scones at me, like that kind of thing? And even like some of like the syntax stuff, I still haven't figured out. Like I still haven't figured out like what should a side input look like in this world? Like how do I like how do I run a query off of some table and cache some data in JavaScript and make it available? You know, figuring out like what the language should look like, and really more than anything, what's the carrot? What is the carrot that gets the analysts to give up SQL and Hive in favor of this? How do I make this compelling for them, right? I can't force them to use it. I can force my own team to use it, kind of. They can also quit and go somewhere else. It's not like data engineers are like, you know, no one wants to hire them or something like that. They're actually all here right now. So hi, Slack data engineering team. Hi, everybody. How's it going? So please don't try to hire my team. No. Yeah. I would love to open source it at some point. I really would.
People are going to hire them if you make them all learn JavaScript.
Yeah. Well, I mean, like, how do you learn? Like, I mean, I feel like JavaScript, you just kind of know it, right? It's just, you just sort of intuit. You look at JavaScript and you're like, okay, this looks stupid. I can do this. I mean, it's not, you know, I'm kind of serious.
Someone else. Let's get off the JavaScript thing.
I'm not taking any questions from Eric Sammer, by the way. That was part of my contractual agreement. It's required no questions. Hey, how you doing?
Hey, doing great.
Good.
Sorry to keep it on JavaScript, but to avoid the horror of JavaScript, have you looked at TypeScript?
TypeScript. I have not looked at TypeScript. I am actually very much amenable to anything aside from, I guess I hear horrible things about CoffeeScript. Like people don't use CoffeeScript, that's a bad thing. I had some Facebook people tell me to look at Flow, which is like sort of a, you know, eventually type, kind of like Hack. Hack is the PHP, is Flow is the JavaScript, roughly speaking. Is TypeScript kind of like that? Is that the same idea?
I would call it basically ES6 with some extra goodies.
Yeah.
Some people call it C# envisioned as JS.
Okay. I mean, like a sort of a groan through the room, right? I mean, guys, we're talking about writing ETL pipelines in JavaScript. The groaning ship has kind of sailed already, right? Like, anyway. That sounds interesting. I will totally check it out. Yeah, thank you. Yes?
So question, so the Spark API is great. I think everyone agrees on that.
Yeah.
But, so why do we need a JavaScript DSL like,
Great
on
question.
top of it?
Great question. Couple of reasons. One, Spark API is great, but you need to actually like write Spark in some fundamental sense. And if you're writing Spark, I sort of sadly lose, in some sense, the opportunity to optimize the overall execution flow. So I like the sort of like declarative aspect, in some sense, of having some kind of configuration language that shows a declarative aspect of it, which is like, I really just need this set of things to happen somehow, and then leave it to like the system, the data engineering system, to figure out in what order that sort of set of things should happen. Spark is great if you like know Spark really well and you know not to do like say group bys and stuff like that, if you know to always do reduce by key, if you know how to tune it properly, all that kind of stuff. I think Spark is great. And I want to say that like it's not like this is a replacement for everything. It's totally not. There are still very core data pipelines that will be written like natively in Scala, in Scalding, in Spark, or whatever, when that makes sense. What I'm trying to do is provide a way for the data analysts who don't necessarily know Scala, don't necessarily know that on AWS S3 you need to set the rack locality to 0 for the wait time for Spark, all that kind of nonsense. I don't really want to have for them to care. The other reason is, while I like Spark a lot for batch processing, I am honestly kind of personally not totally sold on Spark streaming as my stream processing engine. The garbage collection stuff just seems really crappy, and I am very ambivalent about a system where I have to restart the goddamn thing every 24 hours to deal with out of memory issues. I'm not savvy enough to know whether that is an intrinsic problem of the Spark programming model or whether that is something that is fixable. I don't think rewriting the whole engine from scratch in the 2.0 thing is the right solution to that problem. That kind of is fucking terrifying. So I've heard good things about Flink. I generally trust the Kafka people and think they can do good stuff. And so just to be perfectly honest and blunt, I kind of want to keep my options open when it comes to choosing a stream processing engine. And I really want the logic the analysts define for creating core metrics for saying, this is a daily active user. This is someone who writes a post. I really want that core logic to be literally identical in my batch and my stream processing systems. I want it for my batch systems for internal A/B testing, experimentation, metrics, all that kind of good stuff. And for the stream processing engine, which is going to be showing end metrics to teams, to admins, saying this is the number of daily active users you've had. Slack has this fair billing policy, right, where we only bill you for people who actually use Slack in a certain way in a given month. And so that stream processing and that batch processing, it has to be identical. It's not an option for it not to be. And so abstracting away from the underlying execution engine gives me some optimization opportunities, doesn't necessarily tie me into Spark streaming in a way that I'm just not super comfortable with yet. So long-winded answer, but that's roughly the philosophy behind it.
Let's do 2 more.
2 more, okay. I saw this guy in the blue shirt here, but where's Pete? Oh, there he is, okay. It's a big thing here, so sorry. Guy, blue shirt, yeah, right there.
Hey, Josh, great talk.
Was it? Thank you.
It was good. It's really good.
I only finished it an hour
Some of the jokes
ago.
were recycled, but that was okay.
Yeah, that's always true, yeah.
So you sort of hinted at different parts of the Slack data engineering stack.
Yeah.
But I was wondering if you could just walk us through what does it look like right now, and what's the future vision for this?
Yeah, that's a great question. What it looks like right now is probably closer to the SQL-centric kind of data engineering worldview. Most of our ETL is, so we use thrift logs. We also have some JSON logs and Apache logs for kind of random one-off event sort of stuff. We ETL all that stuff primarily using Hive into Parquet. We do the vast majority of our interactive query via Presto. We do some roll-ups on that data, and we store it in a MySQL database for powering dashboards and bots and all that kind of stuff. We do a big-ass, ridiculous replication job to replicate our prod MySQL data, which is sharded all kinds of dozens of different ways, using a tool called Scooper Duper, which basically spins up a copy of Slack and just hoovers data right out of it. Everything is S3, everything is Parquet. Little bit of Scalding for some things where Scalding was a better fit, a little bit of Spark for some things where Spark was a better fit, that kind of thing. That's sort of the world we inhabit at the moment. Yeah, I don't know. Like I said, carrot stick kind of situation. I can't force the analysts to give up Hive and stuff like that. If they want to use Hive, then we'll just spin up more clusters and drive up our ops budget accordingly and stuff like that. My sort of carrot for them, though, more than anything, is what I was just saying about having the core metrics defined exactly the same way in the batch world and the streaming world. If the true metric that defines our core logic is defined in SQL and defined in Hive, it's going to be fucking impossible to keep it in sync with whatever stream processing engine we end up with, even if underneath the covers they're still processing fundamentally the same logs data off of Kafka or whatever. So yeah, that's a great question. I probably should have thrown a slide up in the talk earlier. So sorry. Thank you for asking that. Yeah, I gotcha. That was so many questions. I'm glad we have office hours. Pete, last question. All right.
Hey, Josh.
Hey, how's it going, man?
What's going on?
Yeah, hanging out, giving a talk.
Awesome. So most of what you've been talking about kind of looks more at the analyst-y SQL reporting layer.
Yeah.
Does anything change in your mind when you're looking at data product
Yeah.
and things that have to go into the apps?
Another great question. These are all things I really should have talked about in the talk. But then again, people get to look really smart by asking me these really interesting questions. So that is a little bit further out of my mind, but is like something I'm definitely keeping in mind. We already, like, so Slack, for instance, has some of our services in production are Java servers that are running like Nashorn essentially to do like scripted aspects of some of our processing. And since we know how to deploy that stuff into production, we're comfortable running it and comfortable monitoring it, I am sort of curious if I can convince our machine learning team in New York to basically build their machine learning algorithms in Scala using all the great stuff Scala has available, but do a lot of their feature engineering in a sort of scripting-ish way on top of like thrift records that are basically being processed using this kind of DSL, and then feeding into the underlying model fitting and scoring stuff underneath. So much so, as part of like Josh Will's fantasy world, where I could pick up a bunch of features that I built, you know, like the actual literal code that was used to generate the features in the offline batch process, and drop it into a server running in production for online model serving. That is my great fantasy. So yes, I am thinking about that. No, I am not tackling that problem quite yet. Yeah.
Awesome.
Cool.
Thanks, Josh.
Good. Thanks, everybody.